Good evening, everyone. Welcome to our introduction to remote sensing of the environment. My name is Shaun Levick from the Gears Lab, and today we move on to image classification. I'd like to start off once again by just acknowledging the Google Earth Engine team and the Earth Engine developers group. Prerequisites for today are, of course, to have a Google Earth Engine account and to have a little bit of background in JavaScript. Now, if you don't have that, please look up the earlier labs under this series. And for those of you watching the video, the link to this GitHub page where I have the typed out and screenshot tutorial can be found in the information description of the video. So the objective for today is to gain understanding of the image classification process and explore ways of turning remotely sensed imagery into land cover maps. We're going to start by loading up an image to work with. We're going to use Landsat 8 surface reflectance data, and we're going to be working in the Cairns region of northeastern Australia. So heading over to our Earth Engine interface, let's type Cairns in the search bar. Cairns City, Queensland, Australia. Click that. We'll zoom in to the town of Cairns. Using the mouse, we'll just zoom out a little bit. This is a tropical city. Here we have the northern edge of the Great Barrier Reef, some tropical forest along the coast, and savanna in the inland. Now, let's continue with our tutorial. The first step we want to do is get a cloud-free image to work with. Building on the labs from last week, we're going to filter to a region of interest using filter bounds. We're going to temporarily filter the image collection using filter date. We'll sort by cloud cover and extract the least cloudy scene. So we're going to start by using the teardrop icon, and we do this so that we have a spatial reference point to query the image collection with. So I'm just going to click here, and I'm going to come up. You'll see that it defaults to the name geometry. I'm going to rename that ROI in small letters, standing for region of interest. Okay, and then let's copy in this bit of script, and before we run it, we'll just run through what it means again. We can paste that in. Okay, now we're going to create a variable called an image, and that image we're going to extract from the Earth Engine image collection, Landsat 8, collection 1, tier 1 surface reflectance. We could also do that by searching for Landsat 8 here and importing it like we've done previously. But if we know the name of the collection, we can just reference it like this. It makes it more automated in future steps. Next, we're going to filter by bounds, and we're going to use the ROI as our spatial location. That's the ROI we created. We're going to filter by date. Remember that this is American style, year, month, day. We're going to sort by cloud cover. There's a metadata property in Landsat 8 imagery with a cloud cover percentage. The default in the sort tool is to sort ascending, so that's from the least cloudy to the most cloudy. And then we use this command first to pull out the first image in that in that specified date range. Then we're going to add this image to the map layer using this command, map add layer image. We're going to specify the bands we want to load. We're going to load up a true color image, so we're going to use bands 4, 3, and 2. That's red, green, blue. And we'll specify a min and max of 0 and 3000. We'll look at that in a bit more detail. Let's hit run. We can see that something's happening, and after a while we'll get a nice cloud-free Landsat 8 image over our area of interest. Landsat scenes are quite large. You can see the scale bar down here, 20 kilometers. We're going to focus for this prac mostly on this area around Cairns. Let's head back to our lab. I put a note, just a note that a reminder, this is where we specify the name of the image we're loading to the map, and that's what gets used here in the Layers tab. Remember, we can flick that on and off as we wish. Now, have a look around the scene, familiarize yourself with the landscape. You'll notice the image is looking a little bit dark. So we can come over back to the Layers tab. If you want to change some properties without playing with the code up here, you can use this cogwheel setting to adjust the brightness a little bit. So I'm going to increase that slightly to 1.4, hit apply, and that'll just bring out some more detail in those darker, shadowy areas for us. So have a look around. Obviously we have the ocean, we have a river coming in, got some good mangroves around here, some forested hills, and you see a lot of agriculture out in these further regions. Now what's our next step? Gathering training data. So the first step in classifying our image is to collect some training data to collect the classifier. We want to collect representative samples of reflectance spectra for each land cover class of interest to us. We're going to use the cloud-free scene as guidance. Hover on the Geometry Imports box next to the Geometry Drawing Tools and click New Layer. Each new layer represents one class in the training data, for example, urban. We're going to call the first layer urban, and let's go through this together. Geometry Imports, New Layer. As I click that, it's called Geometry. Again, it always defaults to Geometry. You can change that to Urban. And the important thing to note is that this is highlighted. If I wanted to collect more points for the ROI, I could just click it. But if I want to collect Urban, click it. Now, when I click the teardrop, it's going to add features to this file. So you see here we have no vertices at the moment. I'm going to click around inside the urban area, and you'll see the number of vertices increasing. For interests of this lab, I'm going to do this very quickly. Ideally, you would want to click on representative features of urban areas around the whole scene. I'm just going to work on this area for now. And I've suggested for this lab that you collect about 25 sample points from urban areas. And let's just, if you make a mistake by clicking on something that's clearly not urban, for example, you can exit, click on the point, and delete it. And then we can continue again. It'll tell us here we have 18 points for urban. I'm going to just quickly collect a few more until we have 25. Okay, now these are 25 locations that we know are definitely urban. But if you read down a bit further, you'll see we need to make some changes to the configuration of this geometry. So at the moment, we have a variable called urban. It's a multi-point geometry with 25 vertices. See this little cogwheel here, configure. If we click that, we'll open up this dialog, configure geometry import. And we're going to change this to a feature collection. We want this to be a feature collection. And we're going to do this with each land class we create. So we're going to have separate feature collections for each land class, but ultimately we're going to merge these into one. And when we merge them into one, we need to have a common land cover system across them. So that's why under properties, we're going to say add property. And let me double check what I called this. Land cover, yes. We're going to call this land cover. And we're going to give it a numeric value. And this always starts at 0. So this first one, urban, the property is going to be land cover, and the value is 0. Okay. That means in a future map, any pixel that's coded as 0 will actually be urban. We can close this. I've added in another point over there. Again, I can just click that and delete. Let's see, which other land classes do we want? If we read down, we're going to add water, forest, and agriculture next. So the way I suggest you do that is you just come down here, say new layer, that'll be the one for water, forest, agriculture. Then I'll come here, type water, forest, agriculture. For each one of these, I'm going to change it to a feature collection, add the land cover property, and now we're going to increment. So we started at 0, water will code water as a 1, forest we will code as a 2, and agriculture we will code as a 3. Okay, now if we look here, that's great. We have water, forest, agriculture, but we haven't collected points yet. So let's click on water, and just quickly, I'm going to collect 25 points. The more training data you have, the better your classification will be, the more options you have for validation. I'm just using the 25 is quite arbitrary, but you want to have an equal number among the classes. So I'm just going to click get these 25 water points, making sure they intersect the image. I'll collect some from inland water as well. Like I mentioned before, ideally you'd be working across the whole scene, but I'm just focusing on this area for today. We'll look at the whole scene in next week's lab. So I'll just get that up to 25. Then likewise with forest, I'm just going to click on forest here, and I'm just going to call all these green hills forest. Of course, you may want to get more detailed in future and split out mangrove forest from other types of tropical forest. Collected a few too many. Doesn't really matter, but I'm just going to delete 3 of these so that we have the same number in each class. Lastly, agriculture. We'll collect a range of agricultural fields, and you can already see that we're going to have some problems if you look at how diverse this agricultural class actually is, where we have bare paddocks, green fields. But for the purposes of learning, this is fine. So we'll click around until we have our 25. Great. Remember to save your script using the save as somewhere in a folder so that you can return to it at any time. And let's go back to our tutorial. We have 4 classes defined: urban, water, forest, agriculture. But before we can use them to collect training data, we need to merge them into a single collection called a feature collection. And we're going to do that by running this line. So let's go through it. We're creating a variable class names, and that's going to equal urban. But look at this, dot merge means we're going to merge urban with water, and we're going to merge that with forest and merge it with agriculture. When we run, you'll see nothing really happens, but we haven't actually asked the system for any feedback. We've just created the variable class names. If we want to see what that looks like, we'll need to print it to the console. So to get feedback, we either need to print to the console or add to the map. So let's print class names, run, and now you'll see the feature collection pops up here. And what's a little strange is that we have 102 elements. I was expecting 100 since we have 4 classes and 24 points. Looks like we've got 27 in agriculture, so it doesn't really matter, but just so that everything we do is the same, I'm going to delete 2 of these agricultural points so that we have 25 elements. Just run the script again. And so now we're printing class names, the feature collection here, 100 elements. And that's because if we go into features, we'll have 100 points here, and these are the points that we've collected as training data. And for any given one, if you go into it and look under properties, you'll see the land cover value. So land cover 0 for water. And if we go down somewhere else, properties, land cover 3, that's an agricultural point. Okay, next up is then to create the training data. We can use the feature collection we created to drill down through the image, through the multiple bands, and extract the reflectance data for each point from every band. This is going to be very valuable data for us in building our classification. So we're going to do that with this bit of code. And remember that along the way you can write some notes to yourselves. So I'm going to copy this in and we'll just go through what it means. The first thing is we're creating a variable called bands, and what we're doing is there's a range of bands in Landsat 8 imagery, and we're just saying we want to use bands 2, 3, and 4. That's blue, green, and red. Band 5 is near infrared. Band 6 and 7 are the shortwave infrared. So I'm going to just make a note here that we choose the bands we want to use. And then the next step, we're making a variable training. And this is actually going to be our training data sets, because we're using a command, a function sample regions, to extract based on the class name for the property land cover, the reflectance values from those bands. So this is then create training data, and this is also, we're going to print that training data to the console. So let's run that, and just remember that so far under properties we only have one value, land cover. When we run this, you'll see there's now 2 feature collections printed up here. The first is the class names, where for each property there's only the land cover. And now the new one that we've created, training, we're going to properties, features, and then feature properties. You'll see that there's now 7 properties. So we know that at that point, in what we've classed as land cover 0, urban, we have this range of reflectance values for the different bands. And that's really powerful. We've effectively merged this information into one geometry. Okay, and that's great because it allows us now to train the classifier and run the classification. So we can train the classifier algorithm by using our examples of what different land cover classes look like from a multispectral perspective. Copy, paste this in. Note to ourselves, this is make the classifier. So we're creating a variable classifier. We're using a cart, a regression tree classifier, and it's going to be based on that training data set using the class property land cover, and the input is going to be the bands that we've chosen up here. We can run that. We haven't asked for any feedback, so we won't see anything new. In order to do that, we're going to first run the classification. We're creating a variable classified image. We're selecting the bands, and we're classifying those based on the classifier that we made up here. Again, we haven't yet asked for any feedback. We're going to do that now. To display the classification, we're going to first center our map using map center object around all these points. So this is just a way of zooming to the extent of the points that you've used. The 11 denotes the zoom level. Remember, that's between 0 and 22. The layer we're going to add to the map is our classified map. And because we've named our classes from 0, 1, 2, and 3, we need to specify that we want to display a range from 0 to 3. And the palette we want to use, these are the colors we want each class to be. So because urban was 0, it will be printed out in red. Water will be in blue. Forest will be in green. Agriculture will be in yellow. And we're going to call that layer classification. When we run this, hopefully it works. And if it does, we should see a categorized map coming up on top of our true color image. So here it comes, and what we can take out of this is that the classification has worked to some extent. We've pulled out the water bodies nicely in blue, some of these urban areas in red, agriculture in yellow, forest in green. Looking out over here, you can see we clearly have some problems because there's a lot of urban mixed up. And if we just turn that layer off, we can see that that's just very dry landscapes. And we're going to have to add in some classes to refine this further. But that's where I wanted to get to today. That's the first step of running your first classification. So if we just come back here at the bottom, examine your results. Congratulations on running the classification, but are you happy with it? How can it be improved? In your own time, try adding in some extra classes for land cover categories that show signs of confusion. And I'd suggest urban agriculture is one we need to tease out. And we'll look at how to refine this further and use some different classification approaches next week. So I hope you found that useful. Remember, you can click on here to go to the YouTube channel with this Introduction to Remote Sensing of Environment playlist. So thanks very much. See you next week. Cheers.